Hi, welcome to chemistry. This is going to be our first lecture, and we are going to start in our notes today. So open up to chapter 1. It will look like this. Chemistry, the science of matter, chapter 1. We're going to be going over physical properties today, chemical properties, and also classification of matter. So we're going to start by defining matter. So if we look at matter here on your notes, matter is anything that takes up space or has volume. That's what having volume means. It takes up space. And it also has to have mass. So matter is anything that takes up space. In other words, taking up space has volume and has mass. Okay, I need to get better at writing on this tablet. Property. A property is anything that I can observe about an object or some matter. So it's observable traits. That matter has. For example, water right here is colorless and clear. At room temperature, it is a liquid. Those are all observable traits of water. Okay? Another thing that we could say about water is when we get to 100 degrees Celsius, it boils. And when we get to 0 degrees Celsius, it freezes. Those are also properties of water. Okay? So I have some copper here. I'm going to move the camera so that you can see into my dish. I put some of the copper in some acids. So those are the bright red ones, the ones that the acid had cleaned. The other copper have been sitting out in the air for a while, the darker brown ones. So you can see what clean copper versus aged copper looks like. Notice the clean copper is really bright red, and the aged copper is more brown. Okay, so let's see if we can describe copper. Think about it for just a little bit. So at room temperature, copper is a solid. You guys see that as solid pieces? So let's write that in our notes. So at room temperature, copper is a solid. And then we also observed the color. Copper is this reddish brown color. Reddish, that's probably got 2 D's in it. Reddish brown in color. Now it's more red the fresher it is, and it's more brown the more oxidized it is. The next thing is copper. Can I dissolve it in water? So let's put some water in this little beaker right here. I'm going to put some copper beads in here. I'm going to swish it around, see if I can mix it up, stir it. Were we successful in dissolving any of the copper in here? Nope. It's all still there. It doesn't dissolve in water, so that's not going to be a property. So when it doesn't dissolve in water, we call that insoluble. That means not dissolvable in water. Notice when we put it in the water, it sinks to the bottom. So that means copper doesn't float. It's more dense than water. So it sinks in the water. Can I attract copper with a magnet? I don't have a magnet here, but have you ever played with pennies and a magnet? Do they ever attract? They don't. So copper is not attracted by a magnet. It's not what we call ferromagnetic. Will it react with hydrochloric acid? That's a good question. So I have some hydrochloric acid here, and I'm going to pour some in this beaker and put some more of the copper in here, I don't want the acid to accidentally splash into my eyes. So I am going to put my goggles on. So here we go. If I put some copper beads in here, do we see any reactivity going on? I don't see any bubbling, any fizzing. I don't see the copper dissolving at all. I don't see any reactivity. So I would say on that question, will copper react with hydrochloric acid? That would be a no. Can I burn copper in air? I don't think I can either. So we're going to give this a go. We're going to light up a Bunsen burner. And I'm going to take some tongs here. I'm going to grab one of the larger copper beads with these tongs and hold it in here for a bit. I don't see much of anything going on. It doesn't burn. So no, I'm going to say that's a no. That doesn't burn. So copper will not burn in air. That's going to be a no as well. Okay, so some of copper's properties had to be tested. We always call these kind of tests experiments. We're going to try and do some of the same things for magnesium. So I've got some magnesium here as well. So if we look at magnesium, it's solid at room temperature, right? What color is it? Kind of a shiny silver color too. So let's put those two things down. So it's a solid at room temperature. And it's a shiny silver color. Okay. Can I mix it with water? That is a good question. All right, so I'm going to empty one of these really quick. Rinse this out. If I put water in here, I'm going to flush this out, a bunch of water. So I've got water in here. If I put magnesium in here, the magnesium, does it dissolve? Not really. Do you see how one of them is kind of floating on the water? Let me put another one in there. Notice that magnesium's really, really not very dense. It is right on that borderline where some of it will float, some of it won't, depending on how it hits the surface of the water. Okay, with the surface tension of the water. So copper or magnesium is insoluble in water. And I will also tell you, because I don't have a magnet here, it's not attracted by a magnet. So it is not magnetic. And it will sink in water, but you saw some of them floating because they hit the water broadside. Will float if placed gently. So if it's placed gently in the water and we can use that surface tension of the water, magnesium is pretty close to the density of water. So it will float. Will it react with hydrochloric acid? Should we put it in the same beaker with the copper? Or should we, let's put this copper, let's clean it out, and I'll start with some fresh. Okay, we'll get some fresh acid so that we're just dealing with the magnesium. Okay, fresh acid, and we'll put in a couple of pieces here. You'll notice immediately that magnesium starts reacting with the acid. It bubbles up and it creates steam. It's getting pretty hot. There's a lot of energy released here. And you know what? When we're done, the metal's all gone. It's completely dissolved in the acid. Okay? So, yeah, magnesium will dissolve and react with hydrochloric acid. And let's do 7. Will it burn in air? So, another experiment here. We're going to start up our Bunsen burner again. We're going to grab a piece of magnesium. And yeah, that burns in air. That will burn. You notice that bright white flame. So yes, magnesium will burn. Okay, so we've just defined a whole lot of properties between copper and magnesium. We're going to do that with some ethanol really quick. We're going to use rubbing alcohol instead. So that's really isopropyl alcohol, but it will react pretty much the same way. So isopropyl alcohol, at room temperature, you'll notice that it is liquid and it is colorless and clear. So it is liquid and it is colorless and clear. Okay, can I mix this with water? For sure. So if I take out my magnesium that was in the water and put rubbing alcohol in here instead, if I can get the magnesium out, you'll notice that it will mix completely. Water and isopropyl alcohol are soluble in each other. And it's a good thing because we use rubbing alcohol in water solutions for a lot of cleaning solutions. You'll notice that when they do a swab of your skin before they give you a shot at the doctor's office, they're using a rubbing alcohol wipe, and that is rubbing alcohol mixed with water. So yeah, it's soluble in water. Okay, does it sink in water? I don't see 2 different layers. It mixes with water. It makes a solution. So it mixes with water. It makes a solution. It makes a uniform mixture. Number 5, is it attracted by a magnet? Once again, I don't have a magnet, but I would say no. I know that I cannot magnetize isopropyl alcohol. Not magnetic. Okay, number 6, will it react with hydrochloric acid? Let's see. I still have my beaker over here of hydrochloric acid that I had the magnesium in. Should we pour some in here? See if it reacts. No, it doesn't react with the hydrochloric acid. So non-reactive with hydrochloric acid. And then last but not least, flammable. Now these wood flints are flammable. I'm going to put one of them in the alcohol so you can see the difference between them burning with the alcohol on it versus one just burning by itself. So I'm going to saturate this one pretty good with alcohol before we light this on fire. So here we go. Let's turn on our Bunsen burner again. Oh my gosh, this doesn't want to go. Okay, so here's our normal wood flint. And that's a pretty normal flame there. Here's the wood flint with the alcohol. Notice the flame is higher and it's brighter. So the alcohol makes it burn a little bit faster with a little bit higher flame. So yes, isopropyl alcohol is flammable. It will burn in air. Okay, so we use these properties that we have observed to classify stuff. So let's learn how we classify things. We like to classify things in science, and you've probably realized that last year in biology, if you took biology last year. There's all kinds of classifications that go on in biology. There's all kinds of classifications that go on in chemistry as well. Okay, so when we look at classify, we like to define or categorize groups of things into classes or groups. Okay, so we like to categorize a group of things into classes, or I would say types, according to shared qualities or properties. Okay, we just talked about a whole bunch of properties. Okay, so we are going to fill in the missing blanks on this chart. Matter. There are two main groups of matter right here. Okay, so we can have I'm trying to think what we've got here, how this chart works. We have pure substances and we have mixtures. So we have pure, oh, wow, what just happened there? That's not what we want to do. Okay. So we have mixtures. And we have pure substances. Okay, and I think I might have that backwards on the chart. Okay. And I do. So let's back that up. But I don't think I have it backwards. Well. Okay, so in pure substances, no, I'm going to keep it the way it is. So this is mixtures and pure substances. Okay, we have two types of mixtures. We have what are called homogeneous mixtures. And we have heterogeneous mixtures. I'm going to just cross this out because I don't like these. Okay, homogeneous are salt solutions. They're solutions. Solutions and homogeneous mixtures mean the same thing. It means it's uniform throughout. That would be like sugar water. That would be like saline solution. Every part of that material is the same as every other part of that material. Heterogeneous, hetero means different. So that means that mixture is not uniform throughout. That means you'll get chunks and bits and pieces of other things around. So heterogeneous would be something that has bits and pieces in it. So that would be like a chocolate chip cookie or sand and water where you have bits and pieces of other things. Pure substances, we have two main pure substances. We have compounds and we have elements. Okay? Pure substances are things that you can write a chemical formula for. So elements are just made out of one type of atom. Compounds are made out of two or more types of atoms. Okay? So let's define the following terms. An element. Elements are made out of one type of atom. For example, the oxygen that we breathe. It has two oxygen molecules together, but it's only oxygen, so it's made out of just one type of atom. Or, for example, the iron that we use to build things, that's just made out of one type of atom, iron. Or another thing that we use a lot, zinc. We will use a lot of zinc, especially as catalysts of things. So that is made out of just one type of element. A compound is also pure, but it's made from two or more types of elements. So an example like that would be water. Water is made out of two hydrogen atoms and one oxygen atom. Another good example of that would be sugar. Sugar is 12 carbons, 22 hydrogens, and 11 oxygen for sugar that you use as table sugar. Notice we have carbons, hydrogens, and oxygens. Another really good, easy one would be salt. So the table salt that you use to flavor your food is made up of sodium and chlorine put together. Okay, so those are pure substances. Those are pure substances. We're going to get into mixtures here. A homogeneous mixture. Homo means same. So that means this mixture is uniform. It's uniform throughout. Another word for homogeneous is solution. So anything that we can put the label of solution to, you know that it's uniform or the same all throughout that mixture. And in a mixture, we have two main things. We have the solute and we have the solvent. So the solute is usually what is dissolved. So if I had sugar water, the solute would be the sugar. As solvent, it is what is doing the dissolving. So that would be the water in the sugar water. Notice we could also do it this way. The solute is the minority portion or the smaller portion, and the solvent is the majority portion or the portion that makes up most of it. Okay? I already told you this. Another word for homogeneous mixture is solution. Okay? Do homogeneous mixtures always involve water? That's the way we usually think of them, but do they have to always involve water? No. So let's go on to our next vocab word. An alloy. How many of you guys have heard of alloys? Especially if you're into cars. Have you heard of alloy wheels? Alloys are just solutions made with various metals. So they're made by mixing metals. Okay, for example, if I have brass, brass is a mixture of zinc and copper. Other examples, air. Air is a solution. Air is a mixture of nitrogen and oxygen. And we've got some other gases going on too. We have argon and carbon dioxide and a bunch of other trace gases here. Nitrogen is about 78%, oxygen is about 21%, argon is about 0.9%, and so on. It just gets smaller from there on out. Okay? Heterogeneous. Hetero means different. So heterogeneous mixture is a non-uniform mixture. Okay, so it will not be uniform all the way through. A good example of a heterogeneous mixture is a chocolate chip cookie, or for example, lotion. You'll have little globs of water in there and little globs of oil in there. It's not uniform throughout. Okay, so let's talk about chemical and physical properties. Chemical properties are properties, it is basically the ability, it could also be the inability of a substance to react, to form something new. Okay, so an example, is it flammable? Will it burn? Will it react? Will it change composition. In some way. All of those are chemical properties. Physical properties are something that I can observe without changing the chemical composition. So these are properties or characteristics that can be observed without changing the chemical composition. Of the object. Okay, for example, if I have this pen right here, I can observe that this part of it is black. I can observe this part of it is coral. I can observe that it's about 7 inches long and maybe 1/4 of an inch thick. I can observe that it will write in the coral color. Those are all physical properties. So color, shape, density, whether it floats on water or not, or how dense it is. Melting point, or the boiling point for water, for example. Water has a melting point of about 0 degrees Celsius. It has a boiling point of 100 degrees Celsius. Okay, all of those, whether it's a solid, a liquid, or a gas, these are all physical properties that I can observe. Okay? So let's go back and look at these properties that we've done and of copper, magnesium, and isopropyl alcohol and describe them as either physical or chemical. So I'm going to change my color of pen here. Let's change color. All right. So solid. Oh, wow. I'm skipping all over the place here. So solid. Copper being a solid, that is a physical property. Reddish brown in color, physical. Is it insoluble in water? We're not asking if it reacts with water. We're just asking if it dissolves. That's physical. Does it sink in water? We're asking about density. That's a physical property. Is it attracted by a magnet? It doesn't change the copper to put it by a magnet. That's a physical property. Will it react with hydrochloric acid? That key word right there, react, that shows you that it's a chemical thing. And burn, that's also a reaction. So this is a chemical property. So let's do the same thing for magnesium. We should pretty much have the same thing. Solid, that's going to be a physical property. Color, physical. Solubility is a physical property. Being magnetic or not is physical. Density is physical. React, here we go, chemical. And burning, that's another reaction. That is chemical. Do you guys see a pattern here? Okay, you should. It is pretty much the same pattern. See if you can get that same pattern going for ethanol. Okay, all right. Chemical versus physical changes. We will do that next time, I think. Pretty much, yeah. We'll call this good today.